So now we're going to solve another system, and this time it has 3 equations and 3 variables, but we're going to use the same concepts from elimination to solve the system. So the first thing I want to do is eliminate the first variable from the second equation. And I'm going to use this first equation to do that. So I need to multiply both sides of the first equation by -2 and add it to the second equation, just like we did the previous problem. So I'll just do this to the side here. -2x1 plus 4x2 minus 2x3 equals +2. And then I'll write the second equation. And we'll do our addition problem. So we add, the x1's cancel out. We get 5x2 minus 5x3 equals 10. And we could simplify this a little, right? We could divide both sides by 5 and get x2 minus x3 equals 2. So I'm going to rewrite my system, and I'm going to keep the first equation the same, even though, yeah, I multiplied it by 2 and used it to change the second equation. I'm going to keep it the same here because I don't want it multiplied by 2. I want it as simple as I can make it. So I'm just going to leave it the way it is. And in the second equation, we're going to use our new version. And the third equation we didn't change. So we have our new system, but it has the same solutions, right? Because we added the same thing to both sides of the second equation, so the solutions are not changed. So next, I want to eliminate the second variable from the third equation, the x2 variable. And I'm going to use the second equation to do that. So I need to multiply this by -5 on both sides. Again, I'll work this out on the side, so this will be -5x2 plus 5x3 equals -10. And I'll write down the third equation, 5x2 plus 2x3 equals 3. And we'll do our addition problem. And yes, the x2 variables are going to cancel out. I get 7x sub 3 equals -7. And I solve for x3, I get -1. So again, I've changed the third equation. I'm going to rewrite the whole system again. I have to write it down correctly. And again, I'm going to keep the second equation the way I had it here because I don't want it multiplied by 5 or -5. But the third equation I have simplified a lot. I get -1. So this form is a common form that ends up being really nice and works to our advantage, and it's called triangular form. And you can see the triangle here, right? And you've got one variable eliminated from the second equation, and you have 2 variables eliminated from the third equation. If you get to this point, you are ready to solve this guy. So what we're going to do is, I know x3 now, so I'm going to plug it into the second equation. And since the second equation only has one other variable, x2, I can then solve for x2. And if I know x2 and x3, I can substitute those back into the first equation, and I can solve for x1. This process is called back substitution. When you get it in this triangular form and you're going to substitute bottom to top, we call it, it's like backwards substitution, right? You're going backwards, you're working your way back up. So we'll do it real quick. I know x3 is -1, so I'm going to plug that in to the second equation and solve for x2. So this looks like x2 plus 1 equals 2, so x2 is equal to +1. So now I know x2 and x3, so I'm going to plug those in to the first equation. So I'll plug in 1 for x2 and -1 for x3, and now it's pretty easy to solve for x1. So this looks like x1 minus 3 equals -1. Add 3 to both sides. I get x1 equals +2. So now I have 3 numbers in my solution. So that's going to be an ordered triple: 2, 1, and -1. You know, in Calc 3, you would probably call this x, y, and z. In linear algebra, we're going to say this is x1, this is x2, this is x3. Right? But it's the same thing. They're just names, right?